Hey, how you doing? We're going to wrap this up this year. This is it. This is the last little bit of new information for the year. We're going to add all this precipitation and clouds and water in the atmosphere. We're going to add that to the underclassmen final. You guys are ready. Let's get started. Okay. Air. Air in the atmosphere is just, we feel wind all the time, but I want to talk about movement vertically. As you go up in the atmosphere, you get cold air. It's less dense, right? Sorry. Cold air is denser, but the air in the higher atmosphere is thinner. That's why the temperature is dropping. It's expanded. All right. We have 4 ways of lifting air. There are 4 methods that this have. We've got orographic lifting, convergence, frontal wedging, and you've got localized convection lifting. All right. 4 ways to get huge chunks of air up. First one, orographic lifting. This is geography based. It's a mountain. Warm air goes up one side of the mountain. There's a dry spot on the next side. Why? Because as the warm, moist air rises, it's going to cool, it's going to condense, it's going to rain. You're going to have a windward and a rain side, and you're going to have a dry side to this mountain. All right, the prevailing wind, the moist air rises, loses temperature, condenses. You got a rainy side and a dry side. The entire Sierra Nevadas do this, and you end up with the Great Basin in the U.S., right? You could see this. This is happening. This one's Vancouver. This is Canada. You've got, again, here, you've got the 4 mechanisms, force parcels to rise, orographic lifting. There's one. Hold on. That's next. Nope, not next. All right. 2. I want to do frontal wedging. Let's do frontal wedging, but that's not on here. So we get rid of that one. Frontal wedging is exactly that. This is why. So after you get the dry side on the mountain, why isn't it dry all the way to the east coast then? Because you've got mixing masses of air. So when you've got warm air and cold air, they're going to move as fronts and patches, and the warm air is going to rise up over the cold air, and that's going to get you mixing, and that's going to get you a storm front. So frontal wedging is going to lift warm air. Convergence is the Florida Peninsula. You've got air blowing from both sides across the peninsula. It's going to meet in the middle. Can't go down. It's got to go up. It's going to rise and lift air, and you're going to continually get uplifting. And as you get that uplifting, you can get afternoon thunderstorms, pop-up showers almost any given day in a Florida summer. That's frontal. That's a convergence. Last one is convection heating. Convection heating is localized convection heating. Okay, so if you have a giant parking lot next to a field and the sun is baking and scorching the asphalt and the field's remaining a little cooler, warm air over the asphalt is going to rise. The cold air from the field is going to move in, and you're going to lift the air over the parking lot. You're going to get a convection current cycling. So localized convective heating is the 4th mechanism to move air vertically. Cool. Those are thermals, hang gliding, eagles, birds of prey use thermals. They lift themselves up with the same hang gliders, all of that. Cool. All right. Moving on. Once you get your air up really high, it cools off, it condenses, and then what? Okay. Back to the basics. 3 cloud types. Cirrus, wispy hair, okay? stratus, layer, cumulus, pile. 3 styles. Then we're going to talk about by altitude. Okay? Because you can mix and match all of those names. So we've got stratus is just a big pile of stuff. Cirrus is big and wispy. And stratus is a layer. Stratus is a layer. Stratus is a layer. Cumulus is the big pile. I can't believe I just started. Apologies. You can have cirrostratus, cumulonimbus, nimbostratus, altocumulus. You can mix and match and do everything. Cumulonimbus is one that's a little different. It's got vertical issues. Okay, all of these others are in layers and in piles of whatever. Cumulonimbus is the huge, towering, dangerous thunderstorms. Okay, the anvil shapes and all that. This is the cumulonimbus cloud. All right. So let's see what else we can do here. What are we? Cirrus, cumulonimbus, cumulus, nimbostratus, alto. So by altitude, you've got high, medium, and low clouds. All right. See, high, medium, low. Your cumulus are low clouds. Your stratus are low clouds. Your nimbostratus, see, this has the nimbostratus actually going across 2 layers. Here, the nimbostratus is definitely stays lower. Here, the nimbostratus definitely stays lower. The nimbostratus here is right on the border between the two. Just so you know. All right. But this might be a better way to think of it. You've got your grid. You've got your cirrus. Well, they're really only at high altitude. You've got your stratus. There's one name for each layer. You've got your cumulus. There's a name for each layer. And then they give another column to this, anything that goes vertical, cumulonimbus. And it starts with the cumulus at the bottom. So maybe this is a good way to look at it. I like that one. We can leave that. This one's pretty similar. These are... did that work? That worked. Because it was right there. Ha. Control T's tab. Well, Control Shift T opens up the tab you just accidentally closed. FYI, tip of the day. See, all semester you waited. That was the first thing you learned all semester that you're going to use later on. Okay. Now that you know how to raise water, big air masses, now you know what the clouds look like. Let's talk a little bit about the precipitation. Basic, simple level. Warm clouds. In warm clouds, you have small drops, or you have dust, you have salt, you have particles that the droplets, the water vapor, will condense on and cling to. And then once it gets heavy enough, it's going to fall and it's going to run through the other drops, and it's going to collide with these others and coalesce and form into a big drop. It can break apart due to instability, but now you've got 2 drops falling. They're going to collide with other things, and it's going to grow. If you've got a nice warm cloud, that is the rain you're going to get. Cold clouds, that's a whole other thing. All right, we're going to start with, nope, because both of those show dangerous cold clouds. All right, here we go. Nimbostratus, NS, right? Let's double check. Yep, nimbostratus, there's our cold cloud. Okay, it's going to rain. All right. The water can actually be super cooled. The water will stay water, droplets, below 0 degrees Celsius. Almost down to -40, which, hey, look, they've got -40 written right there. All right. Below that, or in this case, in altitude above that, it is definitely frozen. It's ice. But you can have ice and super cooled water in here. Little bitty ice crystals. The thing is, by the time it gets to the bottom, it's all It's going to be water. There's water over here, right? Okay. You need this crystalline structure like ice for these drops to freeze. And then they fall out when they get heavy enough. The other thing that can happen, if you've got big updrafts in a storm, you ever hail? What's hail? Take this water, run it up here, freeze some ice on it, let it fall. The winds are still going up, run it back up here, freeze some ice on it, fall. Run it up, wind, grow some ice, fall. Grow some ice, fall. And you're going to keep doing that until it gets so heavy that it falls out in the rate. So if there are strong updrafts, you can have crazy hail. Bigger the hail, the bigger the updraft that caused it. All right. So it has been a funky year. I hope you've gotten some good earth science this year. All right. Your final, I'm going to go ahead. So I was reminded that there's Red Day, Black Day. So I'm going to go ahead and open it. You can take it Thursday, Friday if you want the, I think Thursday, Friday is the Black Day version. And then you can take it Monday, Tuesday if you want the Red Day version. That's up to you. It will be open those 4 days. Take it any of that period. Enjoy the rest of your semester. Enjoy your summer. We'll see you back here next year.